Hello everyone, welcome to the Introduction to Mechanical and Industrial Engineering class. This is the part 3 of Mechanical Design. Mechanical Design, this is the first subject of this course. We said that we are going to discuss multiple subjects which are related to the mechanical engineering and industrial engineering throughout this course. And the objective is just to give you an overview about these different subjects which are important to both mechanical and industrial engineers. In the mechanical design, this is the part 3. It means that we have covered before 2 parts for the mechanical design. In the previous 2 parts, in part 1, we discussed the engineering design in general. From the general perspective of engineering, we have discussed the general procedure, the 10 steps that we have to apply in order to do design for any engineering system, whatever it is related to mechanical, industrial, civil, or electrical engineering even. Also, in part 2, we discussed the most common types of mechanical component that we are using as mechanical and industrial engineer, or in other words, these are the mechanical components that would be used for making machines. Any machine, it should contain multiple or different mechanical components who are working together. Some of these mechanical components could be used for giving support to other movable components, while some others which would be used for making mechanisms like gears, belt drive, clutches, and couplings. All these different mechanical components that have been discussed over the previous video, even we have discussed them and their functions and their implementation and use for the automotive applications or in vehicles. And we discussed the transmission system of the car, how it works, especially the manual car. This is what we discussed over the previous lectures for the previous 2 parts. This is part 3, and in this part 3 and 4, actually in part 3 and 4, we're gonna focus over this part. As we mentioned, the objective in order to do design, you should have some knowledge in certain different subjects and topics which are related to the mechanical and industrial engineering. We have discussed over the part 2 the different components, the machine elements and their functions and their operating principle and how the transmission system is working. This had been covered over part 2. In part 3, we are going to discuss the unit system and conversion force analysis. Then in part 4, we are going to discuss the other parts. This is part 3 and part 4. In these 2 parts of the mechanical design, we're gonna give you an overview of the type of knowledge that you should have in order to do design, detailed design and analysis. If you remember in the 10 steps, there was one of these 10 steps is the detailed design and analysis. And as I've mentioned before that your objective in this part is to do some calculations, design calculation in order to design the different mechanical components that making the mechanical system that you're already designing. Like, for example, if we're gonna consider the shafts, we have discussed the shafts and their operating principle, the gears, how they are working and their functions and their use and the different types of gears. So, but in order to design a shaft, in order to design a gear for a specific machine, this design requires some calculation, some procedure that you have to apply. This calculation and the procedure in order to design all of these different mechanical components that we have covered in part 2, this will be covered in another course or 2 courses which are the mechanical design. But in order to be able to study these courses, to be qualified to take the mechanical design courses, there are some prerequisite courses that you have to finish first. These prerequisite courses are related to the engineering mechanics, engineering material. In these courses that you are going to discuss the force analysis, stresses, tensile stress, engineering material, the dynamics, factor of safety. So these different topics will be covered in these courses to be qualified to study for the mechanical design, to know how you can do design analysis, to do the calculation, to design a shaft, to do the calculation to design a gear, to do calculation to design a clutch or a coupling. So these mechanical components, in order to design them, you should study some material, some courses first. So in this part, in these 2 parts, part 3 and 4, I'm just gonna go over these different topics, just an overview as we agreed. This course is just to give you an overview what you are going to study, what kind of knowledge that you should have in order to be able to do design, to do manufacturing, to do industrial engineering, to do anything that related to your major. One of these things that these are the different topics that you should have knowledge in order to be able to do design analysis and calculation for the design of the different mechanical components that we already discussed over the part 2 before. Okay, so these things had been covered. This part have been finished in part 2. In part 3 and 4 we are going to discuss these different topics. Make sense? So in part 3 we are going to discuss the unit systems and conversion in addition to the force analysis, and this part 3 will be covered over 2 lectures or 2 videos. So part 3 will be covered over 2 videos. Part 4 also will be covered over 2 videos, which will be cover this part of the detailed design and analysis. Make sense? So let us move here to something very important to discuss first, which is a physical quantity. What does it mean it is? A physical quantity, as written here in the definition, it is a measure. So what does it measure, or a description? A measure is something that describes a physical phenomenon that exists in reality or in life. For example, every day in the morning the sun rises. So the sunrise, it is a physical phenomenon. So this is what does it mean, a physical phenomenon. Anything that is happening in our life, it is a physical phenomenon. Anything that we can see, anything that we can touch, anything that we experience in our life, it is a physical phenomenon. It can be described by physics. And anything that is described by physics, it can be classified as a physical phenomenon. Like as I said, the sunrise, it is a phenomenon that is happening in our life. The sunset, it is another phenomenon. The rotation of the earth about its center, it is a phenomenon. The rotation of the earth around the sun, every one single year, it is a phenomenon. So all of these are different phenomena. So we are experiencing different phenomena that is happening in our life. Some of these phenomena can be described with some physical laws, which in that case we're gonna name them as physical phenomena. So when we're gonna think about a physical quantity, it is something that describes this physical phenomena. Like for example, like let us consider the rotation of the earth around the sun. This is a physical phenomenon that happens every year. Every year the earth should complete or should finish one complete cycle around the earth, the sun. The earth should complete or finish one complete cycle around the sun every year. So this is a physical phenomenon that every year is happening. Can we describe it? How we can describe this physical phenomenon? One of the things, for example, in physics, we can describe it that we're gonna say that the earth rotates around the sun every 1 year. So this is gonna be the time needed to accomplish or to complete one cycle around the sun. This time, it is a physical quantity. That we're gonna say that the earth completes one cycle around the sun every 365.256 days. So this number, days, it is a physical quantity. Physical quantity that describe or measure. Measure, it means describe. Describe a physical phenomena, which is the time needed for the earth to rotate one complete cycle around the sun. This is a physical phenomena. To be described, it requires a physical quantity. This physical quantity, it is 365.56 days. This is the physical quantity itself that gives a value, that gives a meaning, that gives a description to this physical phenomenon, which is the rotation of the earth around the sun. So the rotation of the earth around the sun, this is the physical phenomenon. How we can describe it? We need a physical quantity or more than physical quantity. Like the time, the 365 days, the 356 days, the 65 days, this is the time. This time it is a physical quantity. Also the distance, the distance of the earth around the sun, it is 154.49 million kilometer. It means that the distance that the earth is going to travel to finish or complete one cycle around the sun, this distance, it is 149.6 million kilometer. This is another physical quantity that describes the physical phenomena, which is the rotation of the earth around the sun. So these physical quantities are very important for us as engineers. As engineer, we are dealing with physical quantity that gives value, that gives meaning, that gives description, that measure a certain physical phenomena that we are interested in as engineer. A typical example of this, the rotation of the earth around the sun. This is the physical phenomena. To be described, we describe this physical phenomena using two physical quantities. One is the time, how long it takes, and the distance, how much of distance that this earth is going to rotate to accomplish one cycle around the sun. Make sense? So the value of a physical quantity, and this is very important, should be expressed in two parts as the product of a number and a unit. Like as I mentioned here, 365.56 days. So this number is the value of this physical quantity. It's the value of the time that the earth takes to complete one cycle around the sun. This is the value. This is the number followed by unit. The unit is days. Like for example, if I ask you, what is the time? You're gonna say that the time, or forget about the time. For example, how long? For example, I'm going to buy a pizza, and this guy is gonna ask me, it's gonna take like 10. He should tell me 10 what? 10 hours, 10 seconds, 10 minutes, or whatever. It means that this 10, it is the number, should followed by a unit. How long as a time to be fully described? To be fully described, you should give a number followed by a time. Because for example, if he tells you 10 and that's it, and you agreed, he have the right to give you this after 10 hours because he didn't specify and you agreed with this. But you should ask him exactly, is it 10 minutes or 10 seconds or 10 hours, right? To be specified. So to fully describe any physical quantity, to be fully described or defined, or to be a full described physical quantity, we should define this physical quantity by a number followed by a unit. Like 365 days, like 149 million kilometers. So the kilometer, this is the unit. But the 149 million, this is the value, this is the number. So it should be a number followed by a unit. So this explains why we are starting by discussing the unit systems and conversions in this part. Here we are interested to know the unit and their importance. The units are important to describe all the physical quantities, and we are as engineer, whatever mechanical or industrial engineer, we are dealing with these physical quantities or these that describe these physical phenomena that happening in our life. So in order to fully describe any physical quantity, you should describe it by a value, by a number that gives it a value followed by a unit. Without the unit, there is no meaning for this physical quantity. There is no meaning for that number. So physical quantities are either basic quantities or derived quantities. So we can group these physical quantities that we are dealing with in our life into two groups, either basic quantities or derived quantities. So I'm just going to give you an example of some of the basic quantities. The basic quantities that found in reality in life are 7, which are the length. Like for example, I could ask you, how much is the length of this pen? So the length, it is a quantity. Describe what? Describe the length of this pen. So the length, it is a physical quantity which is basic. What does it mean, basics? I'm gonna let you know. The mass, for example, how much, which describe the weight of objects. Like it is related somehow to the weight of the object. Like for example, you're gonna buy like 2 kilograms of any vegetable item like tomato, mango, anything. Okay, so 2 kilograms, 3 kilograms, whatever, this is a unit for a mass. So it is a description of a mass. The mass, it is a physical quantity that describe how heavy or describe the weight of objects that we are using in life. For example, all objects in life, they do have certain mass except the photon of light. The photon of the light, this is massless. Its mass is almost 0. But anything that we are experiencing in life, even the electron inside the atom, it has a mass and it is measurable. we do have a certain value for the mass, and we know the value for the mass for the electron. The charge, anything, the charger is like the photon of the light itself. Forget about it. But even anything, it has a mass in this light. Like this pen, it has a certain mass. So it is a physical quantity that describes the weight. How heavy or how light is this pen in comparison to this cell phone. So for example, I told you to compare between the weight of this one and the weight of this one. Who is heavy? You're going to tell me that this one is more heavier than the pen. Why? It has bigger mass than this one. So the mass is a physical quantity that describes something in life. The time, it is a physical quantity that describes for example, the process, the time needed to accomplish a certain process. We can describe the time by a second, by hour, by minute, right? The electric current, this electric current describes the movement of electrons in an electrical wire. From physics, we knew that if you have an electrical wire, and for this wire to be conductor, it means conducting electricity or allow for electricity. It means that it should allow for the movement of the electron. There should be electrons, like so many electrons are moving through this electrical wire. So that's why we're saying that it is a conductor. It is a medium for moving the electron through the wire. And we can measure or describe the flow, the speed by which these electrons are moving through the wire by an electrical current. So the electrical current, it is a physical quantity that describes something, that describes a phenomenon. This phenomenon is the movement of electrons through the wire. This is a physical phenomenon. How we can describe it? How we can describe the speed by which these electrons are moving? This requires a physical quantity, which is the electrical current. The temperature, it is also another physical quantity that describes how hot or cold any object. Is it hot or cold? So this also can be described by the temperature. The temperature of the weather, it is a physical quantity. We may have a hot weather, we could have a tropical weather. So the temperature itself, it is or icy weather. For example, so the description of the temperature or the description of how hot or cold something or object or weather, this requires a temperature. Amount of substance, for example, the amount of substance, this is measured in mole. This amount of substance, for example, it describes how many atoms are needed to form 1 mole of the material. For example, it is known that for many materials, for all materials, that the 1 mole should contain 6.023 times 10 to the power 23 atoms in 1 mole of a material. Like if you have a material, this pen is made of a certain material, made of plastic, made of copper, made of any material. If we choose a small box of this material, and for some reason, we are interested in counting how many atoms are inside this material, this small box, are forming this material. We knew from physics that any material, it is a composition of so many atoms. You have so many atoms are arranged together, millions of atoms to form, combine together to form the material as we are seeing. But you cannot see, we cannot see the atom by the naked eye. We have to look at it through the microscope. Why? The atom size, it is too small. But there are atoms there. If you zoom them through the microscope to this material, you can see the atoms. Make sense? So we have so millions of atoms forming any small piece of the material. If we are interested in counting how many atoms, we should calculate the amount of the substance. This amount of substance, it is a physical quantity that describes how many atoms are existing in any material. The light intensity, as I said, the light, it is measured by photons. The light is the movement of the photons through a space or through anything. Light can move in space. It doesn't require medium like the electron. The electrons require a conductor electrical wire. So the electron can move through it, and we can describe the speed by which these electrons are moving by the electric current. So the electric current is a physical quantity that describes a physical phenomenon, which is the movement of electrons. The same thing for the light. Light, it is the movement of photons. These photons of the light, how many photons are moving, the intensity or the count or the speed, all of this is related to the light intensity. How these photons are moving from one place to the other place to give light, this is the movement of the photon can be described somehow by the light intensity. So that's why the light intensity, it is a physical quantity that describes a physical phenomenon, which is the movement of the photons of light. Make sense? So all of these are physical quantities, and there are more physical quantities that describe many physical phenomena that we experience in our life. But these 7 quantities, these 7 physical quantities are known as the basic quantities or base quantities. What does it mean, basic quantities? So the physical quantities in life, there are so many. They are not just 7. There are millions of physical quantities. Okay? But we can group them into 2 groups. One group is known as base or basic quantity. The second group are derived quantities. So the physical quantities that we are using to describe any physical phenomena are 2 groups, either base quantities or derived quantities. So what does it mean, a base quantities? Base quantities are only 7. There is no more. But the derived quantity could be any number. We don't have so many derived quantities. These base units, these are the basic unit. They are independent and does not require any other quantity to be formed. They cannot be formed. They cannot be broken down. It is arbitrarily defined rather than being derived from a combination of other physical quantities. So, to explain this point, let us consider, for example, the force. What is the force? It is a physical quantity that describe what? That describe how hard, for example, you are pressing over a surface. For example, I can put my hand over your shoulder and press hard. So to describe how hard I'm pressing over your shoulder, it should be described by a force or a pressure. So the pressure, force, these are physical quantities that describe something that is happening. I'm pressing over this table hard with my hand. So to describe how hard I'm pressing over this table, this required force or pressure. So these are physical quantities that describe how hard I'm pressing over this table. So let us consider the force, for example. So the force is a physical quantity, but the question is it derived or basic? Physical quantity, we do have 2 categories, base or basic quantity or derived quantity. So the force, it is a derived quantity. Why? It can be broken down. The force, and we knew this from physics, force, it is the multiplication of mass times the acceleration. It means it can be split into other quantities. Mass, it is a physical quantity, right? That describe how heavy are objects. The acceleration, it describes the rate of a change of the speed. So the acceleration, it is a physical quantity that describes something that is happening in reality, that describes a certain physical phenomenon. So the acceleration, it is another physical quantity. So the force, which is one physical quantity, it can be broken down into mass times the multiplication of mass times acceleration. Even the acceleration itself, you can break it down. The acceleration, we knew from physics that the acceleration A, it is the length or the distance divided by the time square. Like, for example, it is the speed over time, or this S, or the distance divided by the time square. Somehow. It means that the acceleration, it can be broken down into time and length. It can be broken down into length and time. So we can say that the force, it is a derived quantity. Derived quantity, it can be derived. It is not a basic quantity. It can be broken down. It can be formed by the multiplication of mass times acceleration. The acceleration itself also, it is a derived quantity. Why? It can be broken down into a length divided by a time square. It can be broken down into length and time. So the acceleration, the force, both are derived quantities. But the mass, the length, the time, the current, the temperature, amount of substance, light intensity, these are basic quantities. None of them can be broken down. None of them can be formed. For example, if I ask you the time, can you write an equation for the time? No, there is no specific equation for the time. It is its own basic quantity. Can you write an equation for the length? No. Can you write an equation for the acceleration? Yes. The acceleration, it is a distance divided by time squared. It is the speed divided by time. Can you write an equation for the speed? Yes. It is length per time. It is distance per time. For example, if I ask you to calculate the distance, the speed of your car. So you're gonna say, okay, I've traveled from Al Ain, for example, to Abu Dhabi in 1 hour. So what will be the average speed? So your objective is just to measure the distance, know the distance from Al Ain to Abu Dhabi. Then if you divided this distance by the time that you spend traveling, you're gonna end up with the speed. It means that you already forming the speed. The speed, which is the velocity of this car, or the speed of the car, it is a derived quantity, can be formed. It has a certain expression, it has a certain equation. It is described by an equation. The same thing, the force, it is the mass times the acceleration. The weight itself, it is a derived quantity. The weight, it is the mass times the gravitational acceleration. We knew from physics that the weight, it is the mass times the gravitational acceleration, right? This is what we knew from physics. So the weight, it is a derived quantity, but the mass, no. Do you have any expression, any equation that describe the mass for any object? No. Do you have any equation or relation that describe the length of any object? No. Do I have any relation for the current, for the time, for the temperature, for the substance, for the light intensity? No. So these are basic quantities that cannot be formed, cannot be broken down, they are working independently. But the derived quantities, we can form them. We can break down them into basic quantities. Like the force, we can break it down into mass, length times length divided by time squared. This is gonna give us a force. So the mass, length, time, all of these are basic quantities. So the basic quantity or the base quantity is independent and does not depend or require any other quantity to be formed. It cannot be formed. It is arbitrarily defined rather than being derived. We cannot drive them. We have to give a value for the length, for the time, for the mass. We cannot drive or form them. There is no certain equation that describes them from a combination of other physical quantities. But the derived quantities, on the other hand, it is a combination of several physical quantities. We can combine that. We're gonna collect the mass with the length with the time to form a force. We're gonna collect the length with the time. Is gonna give us speed. It's gonna give us acceleration, for example. So it means that the derived quantity can be formed by combining multiple different physical quantities together to form or to give a derived quantity. A derived quantity can be broken down to a combination of the base quantities. We can break them down into the base quantities as already given here. And the base quantities are only 7, which are length, time, mass, and so on. In engineering, especially mechanical and industrial engineering, for all engineering measure, these 3 quantities are the most important basic quantities: length, mass, and time. And we can describe around 90% of the physical quantities that we are dealing with as engineer are describable by the length, mass, and time. Everything. In some other physical quantities which are more related to the electrical engineering, we should need definitely the electric current. Also, as mechanical engineering application, we need the temperature. For material science work, to know about materials and how atoms are arranged inside the atom and the material and how the count of these atoms which are related to the material type, this also is required the amount of substance which should be measured in mole. The light intensity also, if we are interested in the physics of light and how these light things are generated, this also requires this measure. But the length, mass, and type, these are the three important things. And this, through this course, since we are not going deeply through these different quantities, so we're just gonna focus on the length, mass, and type through this course. Make sense? But the other quantities that can be formed by combining two or three of these physical quantities, this known as the derived quantities, like force, for example, like the acceleration. Make sense? So, as I mentioned, the objective is just to know, as we discussed, to fully describe any physical quantity, you should have value, you should give it a value, followed by a unit. Like when we describe the length, I'm gonna tell you that the length of this pen, it is 10 or 20 or 15. None of these numbers make sense. Why? Because 10 it should be followed by a unit. Like 10 centimeters. For example, I'm gonna tell you, if you ask me how long, what is the length of this pen, I'm gonna tell you, okay, it is like around 10 centimeters. I have to mention a unit. So the centimeter, so we do have here the physical quantity, which is the length 10 centimeter. So the centimeter, this is the unit, and this is the value of this physical quantity. Both are describing one single physical quantity, which is the length of this pen. Make sense? The same thing for the mass. I can give the mass, for example, I can measure it in pound, like 10 pound, as it is already done in the United States, or 10 kilograms. Or 10 grams or whatever. So 10, it is the number followed by a unit. It's gonna give a different value. So this combination of the number unit gives a full description of a physical quantity. Like time, I can mention the time in terms of seconds, in terms of hours, in terms of minutes. So all of these are different units that describe a time. The same thing for the current, it could be in ampere, for example. So there are different units, and in general we do have two groups of unit systems. So that's why it is a system. System, it means that a group of units working to describe the different physical phenomena or quantities that we are using as engineers. We have two types of unit systems. We do have the international and the US system, the American system and the international system. International system of units, which is abbreviated as SI system, it is commonly known as the metric system. And this is the type of unit that we are using here in the UE, and in over 90% of the countries or 95% of the countries in the world, we are using the international system of units. We do have the other system, which is the United States customary system, USCS system, known as the inch system or the American system. So we do have two unit systems. We do have the metric system, like for example, you describe the speed by meter per second. This is a metric system. You describe the length by meter, centimeter, kilometer, megameter. So all of these are unit systems that describe the length of objects, but according to the international system of units, which is SI system or metric system. We have another way of describing the length. We can describe the length by the inch, like this is 10 inches or 20 feet. Feet, inch, these are the American system. Like for example, if you're driving over the road and there is a speed limit, do you know the speed limit signal or sign? If there is a speed limit sign that's written as 100 kilometer per hour. So the kilometer per hour, this is a metric system. This is international system. The same sign in the United States, it is written as 70 mile per hour. So the mile per hour, it is a different unit system. It is inch system or American system. So we have different units that describe the same physical quantity. We are talking about the speed limit in both countries, in two countries, in the UE and the United States. In the UE, we are using the kilometer per hour as a unit to describe the speed limits. There in the United States, 70, it is mile per hour to describe the speed limits in the United States. Make sense? So we do have two unit systems that we are using them in different engineering applications to describe all the physical quantities that we are using. This is the only two unit system that we are using. Some countries are following this, the international many. As I said, 95% of countries in the world, all Europe and the Middle East, who are using the SI unit system, but there are some other countries who are using the American system for their units for the describing all the physical quantities. Make sense? So let us discuss this unit system, and especially the basic quantities, these 7 quantities. What are their units if we decided to describe them in the SI system? Like the lengths. In SI system, it can be described by meter, centimeter, millimeter, nanometer. So it is international system unit of describing the lengths as a basic quantity. But the lengths in the American system, it's gonna be described by inch, feet. Inch or feet or mile, for example. These are American systems. The mass in the international system is described by grams, kilograms. This is how we are dealing. For example, if you buy a tomato, so you should have by 1 kilograms or 2 grams or 3 kilograms. So the unit, it should be in kilograms or grams at least. If we're gonna talk about the gold, jewelries and these things, you buy them in grams, not in kilograms, because they are very expensive, right? So it means that the gram or the kilogram, it is a unit of describing the mass. The time in the international system, it is described by second, hour, minutes. But how about the American system? The mass in the American system, it is measured in a slug or in pound. For example, if you are in the United States and you decided to go to Walmart, this is like Carrefour here in the UE, and to buy some vegetables, so you're gonna buy like 2 pounds of tomato, not 2 kilograms. There is no kilogram there. The unit system entirely, it is in pound for the weights. So the mass is described in the American system in a slug, in pound, not grams or kilograms. Grams, kilograms, this is the SI system. The same thing for the other physical quantities, these 7 basic quantities. So let us know how these basic quantities are described in the SI system first. Let us discuss here, we are discussing the SI unit system. Then I'm gonna show you how the same 7 quantities, how they are described or their units in the US system, unit system, how it works. So in these basic quantities are defined using the following basic unit. I'm gonna discuss to you I'm gonna explain what does it mean basic unit. Remember that we do have basic quantity and we do have another thing, basic unit. Forget about the basic unit thing for now. How we are describing the basic quantities, or what is the unit of the basic quantities, which are the 7 in the international system, SI system. So the lengths in the SI system, it could be measured in meter, centimeter, millimeter, nanometer, and so on. So, but all of these are different ways, are different units. For example, if I ask you what is the length of this pen, you're gonna say that it is 100 millimeter, which is equivalent to 10 centimeter, or equivalent to 0.1 meter. So it's up to you. You can describe the lengths in meter, you can describe it in centimeter, in millimeter, in nanometer, even micrometer. It's up to you. But anyway, you have to give me the number that is equivalent and matches the unit. So the number and the unit should be equivalent to describe the same object, the same length. No matter what is the unit that you are going to use, you could use centimeter, millimeter, meter, it's up to you. But the question is, one of all of these so many units, one of them is a basic unit, is a common unit as defined by this system. In the SI system, the basic unit for the length, it is meter. It means that if you are required to stick to the standard, this is the standard of the SI unit system. Of the SI unit system, the length, any length that you are going to describe, you should describe it in terms of meter. Like you're gonna tell me that the length of this pen, it is 0.1 or 0.2 meter. If you are required to stick to the standard, how these lengths are defined in the SI unit system. But how about the other units? If the meter is the basic, how about the centimeter, the millimeter? These are derived units. So we do have, just to not be confused, we do have quantities, which are basic quantities and derived quantities. The same thing for the units. The units, we do have basic unit and derived unit. The basic unit is the unit as defined in the standard book. There is like a standard book for that defined by the SI unit system. Okay, so this, and it has organization. This organization that defined this unit system that we are using as engineering in the world had defined the lengths using a basic unit, which is meter. If you decided to use it, that is fine. If you would like to use any other unit will be considered derived unit, not a basic unit. So what is the basic unit of the length? It is meter. But the centimeter, it is a derived unit. Make sense? The same thing. What is the basic unit of the mass? It is kilograms. The basic unit for the mass, it is kilograms. Like for example, if you buy 10 kilograms, 20 kilograms of anything, so it is basic unit. But the gram, it is a derived unit. Megagrams, it is a derived unit. I can describe the mass by grams or kilograms. This is the common thing, right? So kilogram, it is the basic unit, but the grams, it is a derived unit. Make sense? The time, it is second. But we can describe the time, for example, by femtosecond, by microsecond, nanosecond, megasecond, by minute, by hour. So the minute, the hour, the mega, the femtosecond, all of these are derived quantities. The basic, derived units. The basic unit is the second, if you decided to describe or to give a unit to the time. The current, it is described by, or its unit, it is ampere. Its basic unit, it is ampere. But I could have, for example, microampere, mega ampere, and so on. But the ampere, it is the basic unit for these basic quantities, which is the electrical current. The temperature, it is in Kelvin. This is its basic unit in the SI system. This is the standard. But for example, if I ask you about the temperature in the of the environment, you're gonna give it to me in terms of Celsius, not in terms of Kelvin. You're gonna say that, okay, it is like around 40 Celsius, for example, degrees. In the United States, for example, we are using they are using the Fahrenheit, for example, as for the temperature, as a unit for the temperature. But according to the standard of the SI unit system, the temperature, its basic unit, it is Kelvin. Then the others, the Celsius and other units that would be used for describing or giving the value for the temperature, they can be derived from this basic unit. The amount of substance, we mentioned before, this amount of substance describe how many atoms are located inside 1 mole. So the mole, it is the basic unit of describing the number of atoms inside one piece or 1 mole of the material that's related to this material, the number of atoms. So the amount of substance, it is measured by its unit, it is mole. This is the standard. The light intensity, it is in candela, which is CD. This is the abbreviation. In terms of candela, this is the basic unit for the unit system. The main 3 things that we're gonna focus on them through this course are the length, mass, and time. You should understand and know that the basic units for the length, it is meter. For the mass, it is kilogram. For the time, it is second. Any other thing like centimeter, millimeter, grams, hour, minute, these are derived units, not basic units for these basic quantities. Make sense? The same thing if we decided to work on the American system. So this is for the SI system. There are some basic units for these basic quantities. For the same 7 basic quantities, what are the basic units in the American system? Like the lengths. The lengths in the American system, it should be measured in inch, in foot or feet. The basic unit, it is foot in the American system. But the inch, it is a derived unit, not a basic unit. The same thing, the mass. In the American system, it is measured in a slug. Its basic unit, it is just slug. But we can measure the mass in pound. The pound, it is a derived unit, not a basic unit for the mass in the American system. The basic unit for the time in the American system is second, exactly the same like the international system. So the American system or the international system, the time is common between them. The time is, its basic unit for both, it is second. But minute, hour, minutes, hour, micro, femtosecond, other things, these are derived units for the time. The electric current, it is in ampere as the SI system. The international system and American system, the current is common in both of them. The temperature in the American system, it is in degree Rankine. It is measured in Rankine, but in the international system, its basic unit, it is Kelvin. So degree Celsius, degree Kelvin, these are international systems. But the American system, it is Fahrenheit, Rankine. These are the temperature units for the American system, and the basic unit is Rankine. Amount of substance is mole in both, in the American and the international. The light intensity also, it is in candelas in terms of for the American system and the international system. So there are some common things in the basic units between the two unit systems, whatever American or international, but there are some different things. Again, the main three things that we're going to focus on through this course are the length, mass, and time. The length in the American system, it is in foot as base unit. Mass, it is in slug. The time, it is in second like the international system. Make sense? So far we have discussed these different physical quantities. We discussed what does it mean physical quantity, and we do have base quantity and derived quantity, and we knew the difference between them. Also, we discussed the 7 basic quantities that we do have in life. We don't have any more. These basic quantities cannot be broken down. Okay, but any other physical quantity that can be formed will be described as derived quantity, like force and acceleration, for example. We can form them. There is a specific equation by which you can find or calculate a force or an acceleration, but there is no equation for the mass. The mass should be measured. You cannot calculate mass. There is no calculation for the mass. Make sense? Then we discussed the basic units for these base quantities in the two systems, the international system and the American system. I skipped this table for now. I'm going to discuss this one, but later. But now let us, just to give you more detail, let us consider this example number 1. It is required here using the basic units. We do have derived units and basic units. Using only the basic units, derive the unit for each of the following physical quantities. These are so many physical quantities. Area, it is a physical quantity that describe the space over a certain surface. Like, what is the area of this table? So your objective is just to, this area describes the space, the free space over this table that you can use. The volume, it is a physical quantity that describes the space that had been occupied by an object. Like, what is the volume of this calculator? It occupies, it takes, it consumes a space of a certain space in the of this object. Like it consumes a certain space. How much this is bit? It is the base space. It is described by a volume. The density, it is related to the weight, not the mass. It is related to the weight more than the mass for a certain object, as I'm going to show you. So these are different physical quantities. All of them are derived quantities. Why? Because none of them is one of the 7. We have 7 basic quantities. Any other quantities, it will be automatically derived quantity. Okay, none of them is length or mass or time or current or whatever. As I mentioned, we're gonna focus over the first 3: length, mass, and time. Right? So here, the area, it is not a length, it is not a mass, it is not a time. It means that this is a derived quantity. It means that there should be an expression for describing an area. The volume, the density, the velocity, the acceleration, the force, all of these are physical quantities which are derived. So what are their basic units? This is the requirement. It is required to write the basic unit for the area, the basic unit for the volume. In the two systems, in the American system and the international system. Make sense? So how we can do it? You have to break down, since this is a derived quantity, you have to break it down into one or more of the basic quantities, which are the length, time, and mass. I said we're gonna focus over these three, but there are some other four. We won't gonna use them, we're just gonna focus over these three. The area. If I ask you what is the area of a circle, you're gonna say it is by r square. R stands for the radius of this area. So it is r square, it means r times r. To square anything, it means that you multiply it twice, like r times r. For example, if I ask you what is the area of the square, you're gonna say that it is the edge times the other edge. The length of this edge times the length of the other edge. So the area in general, it is the multiplication of a length times another length. Like the area of a rectangular shape, the area of a square shape. Make sense? So the area, it is the multiplication of a length, which is a basic quantity, times another length, which is also a basic quantity. Referring to this previous table, in the SI system, what is the base unit or the basic unit for the length? It shouldn't be in meter. We can measure the length, as I mentioned, in meter, centimeter, and so on, but the base unit is meter. So in meter, this is in the SI unit, so it means that this length, it should be in meter, times the other length, which it should be in meter also. So meters times meter gives meter square. So the base unit for the area in the SI system, it is meter square. Make sense? How about the American system? The length, we said that the area, it can be broken down into length times length, the multiplication of two lengths, right? This is for the area. So if you're gonna go to, so it is length times length, go to this table for the US system. The base unit for the length is feet or foot. So it means that the length, the first length is gonna take foot, times the second length also is gonna take foot. So foot times foot gives foot square or feet square. So it means that the basic unit for the area in the American system, it is feet square. Make sense? How about the volume? The volume, simply, it is the multiplication of three lengths. Like, for example, if I ask you the volume of a cuboid, you're going to say that it is the multiplication of the length times the width times the height. So it is the multiplication of the three edges of the cuboid shape. So length times another length times another length. So this length describes the length of these edges, three edges. So we're going to say that the volume in general, it is the composition, it can be formed as a multiplication of three lengths. So in metric system or the SI system, the length is measured in meter, and the second length will be in meter times meter. So the multiplication of 3 meters gives meter cube. So the base unit for the SI system, for the volume, it will be meter cube. For the US system, it will be feet or foot times foot times foot, 3 times. This is gonna give us foot cube. How about the density? We knew from physics that the density equals mass divided by volume. This is the fundamental law for the density. This is what we knew from physics. Density, it is mass divided by volume, right? The mass, can be broken down? Can we break down the mass? No, the mass is a basic unit. Remember that we're gonna focus over 3 base units, the basic quantities, which are the length, the mass, and the time. So the mass, it cannot be broken down. It is a basic quantity. So we're just gonna have the mass as it is. But the volume, it is a derived quantity that can be formed as multiplication of 3 lengths. So that's why we can write this density as mass divided by L cube. Remember, something that I forgot. Why I'm adding these brackets? This is square brackets and L, it means that this is a dimension, that this quantity should have a dimension of a length. Dimension, it means that its unit, it should be the unit of a length. So that's why this is what does it mean, why I'm including this square bracket. So this square bracket indicates that this is the dimension, not a length exactly, a dimension of a length. It means that we have to substitute here for the unit, for this length. Okay? That just to explain to you why I'm adding this square bracket, and don't give it mind that much. It is just something to know. Okay, but anyway, the density, for example, it is a mass divided by a volume, and a volume, it is the multiplication of three lengths, of three quantities that describe by length times length times length. So that's why it is already meter by length is cube. What is the basic unit of the mass in the international system? The basic unit for the mass for the international system is kilograms. So the mass, it will be in kilograms. But what is the basic unit for in the international system for the length? It should be in meter. So it should be in meter, and since the length it is cubed, so the meter also should be cubed. So that's why it is kilogram per meter cube, and this is the basic unit for the density in the international system. How about the same unit but for the American system? What is the basic unit for the American system? For the mass, it is in a slug. This is the basic unit for the American system for the mass. It is in a slug. So the mass, it should be in a slug. How about the length? In the American system, it should be in foot. So it should be foot cubed. So it will be foot cubed. So it's going to be slug over foot cube, which represent the mass over the length cube, which represent the density. So the basic unit for the density in the American system, it should be slug over foot cube. And so on. For the velocity, for example, the speed, or the speed of the car or whatever. So it should be length as a distance over time. We said that from physics, we knew that the velocity, it is a distance over time. The traveling distance over the average time, or the time. So the distance, it is measured by a length, like 5 kilometers, 6 kilometers, 5 meters, 5, 6 meters, centimeter, and so on. So it means that the length, it is measurable or measured by a length. This is the distance. Over time, it's just time. So the velocity, we're going to say that the velocity, it is a length divided by time. What is the basic unit for the length in the international system? It is in meter. In the both international and American system, it is in seconds. So that's why the basic unit for the velocity in the international system, it is meter per second. But for the American system, it is foot per second. In the American system, the basic unit for the length, it is foot. And the time, it is in seconds, so it's going to be foot per second. The acceleration, it is speed or velocity over time. It is velocity over time. It means that you're going to divide with one more time. Like it's going to be, the velocity should be length over time, and there should be another time, times. So times the multiplication of 2 times. Okay? And we're going to add the square brackets here, which can be written as length divided by t squared. The length, the basic unit for the length in the American and the international system, it is meter. The time, it is in seconds, so that's why it is meter per second squared. This is the basic unit for the acceleration. But the basic unit for the American system for the acceleration, it is in foot over second squared. Foot, why? Because the length in the American system, it is in foot, and the time is still in the second, so it's going to be foot over second squared. How about the force? The force in general, the force equation, it is mass times acceleration. The force, any force, whatever it is, according to Newton's law from physics, Newton has defined the force as a mass times acceleration. The mass, it is a basic quantity that cannot be broken down. So the mass, it will be just mass. But the acceleration, it is a derived quantity that can be formed as a length divided by a time squared, as we expressed before, right? So simply we're going to say that the force is the multiplication of mass times length divided by time squared. What is the basic unit of the length in the international system? It is in kilograms. So the mass, if we just going to write this thing as mass times length over time, this is the force. Make sense? So what is the basic unit? For the mass in the international system, it is in kilograms. Times, what is the length? The basic unit of the length in the international system, it is in meter. What is the basic unit of the time in the international system? It is in second. So kilograms times meter per second square. I'm sorry, this should be time square because this is acceleration should be length over time square. So that's why this should be second square. So it's going to be kilogram times meter over second square. This is the basic unit for the force. This is the basic unit for the force. So what is the basic unit for the force? And in the international system, it is kilograms times meter per second square. This is equivalent to Newton. Newton as a unit. Newton, it is a unit, not a force. Newton, it is a unit that describes a force. So the Newton, it is equivalent to kilograms times meter per second squared. We knew these things before. I know that some of you already have aware or have experienced this relation before, or knew that Newton, it is kilograms times meter per second squared. But this is in the international system. In the American system, the force, it is measured in pound, which is equivalent to Newton in the international system. The pound, but the pound, it is not the basic, it is the basic unit, yes, but how we are forming the pound. If we did the same as we did here if we do the same as we did for the international, for the American system, what is the basic unit for the mass in the international, in the US system? For the mass, the basic unit for the mass in the US system, it is in slug times the length in the US system, it should be in foot, divided by the time, which is second square. So slug times foot over second square, this gives the basic unit for the force in the US system, which is equivalent to pound. So the pound, it is equivalent to slug times foot divided by second square. This is simply how we can form the basic units for any physical quantity, whatever it is. Make sense? So what we discussed so far here, what we have discussed so far, we discussed that we do have physical quantities. What does it mean, physical quantity? And what does it mean, physical phenomena? We discussed also that any physical quantity, to be fully described and correctly described, you should use a number followed by a unit. And the number and the unit should be consistent together. Also, we grew the physical quantities into base quantities and derived quantities. And we distinguish between them. Basic quantities are 7 only, and we said that we're gonna focus over these 3, which are length, mass, and time. Any other quantities can be formed by these 7 quantities, and we do have 2 systems, whatever international system or the American system. I showed you over this table. This table shows the basic unit for these basic quantities in the international system and this one in the American system. Then we'll consider these examples of how we can express the various different physical quantities. We have so many physical quantities, not just the 7. The 7 are the basics. In other quantities, in other quantity will be derived quantity, but we have so many of them. So any one of these physical quantities, how we can express them using their basic unit in the American or the international system, this is what we discussed over this example number 1. Make sense? Let us consider also another example here, which is example 2. Knowing that a moment, when you from physics, a moment is something that would be used for giving rotation to any object, and this will be explained as we move in this part. We're gonna discuss this moment thing and what does it mean, force and moment, with more detail. But knowing that the moment, it is the multiplication. So the moment, we're gonna say that the moment in general, it is the multiplication. It means equals multiplication of a force. So it means it is the multiplication of 2 things. A force times distance. So it is the multiplication of a force times this multiplication indicate times distance. So he tells us, assume or knowing that the moment, it is a force times distance. And this is true. We knew from physics that the moment, it is the multiplication of force times distance. Derive its units. in both the SI and US unit system. What is the basic unit? For the moment, I'm not seeking the force, I'm not seeking the distance. I'm seeking the unit for the moment from both the SI and the US, the international and the American system. So the moment it is a derived quantity. Why? It had been broken down as multiplication of two quantities. Then I have to investigate these two quantities, the force and the distance. Which one is derived, which one is basic? If the force is a basic quantity, no, it is not one of the seven. So it means that it is derived quantity as well. Can we break it down? Yes, we can break down the force as we discussed here. We said that the force is the multiplication of mass times acceleration. It means that I can break down this force into mass times acceleration. This is just the force times the distance. The distance, can we break it down? The distance, it is measured by a length. The distance cannot be broken down anymore. It is already a basic quantity. The distance, it is like length. What is the unit of any distance? What is the distance? If I ask you the distance from Al Ain to Abu Dhabi, you're going to say that it is like around 100 kilometers. So kilometer, it is a measure of a length. And the length, it is a basic quantity. It means that the distance itself, it is a basic quantity. So I can simply even replace this distance by length. I could say that it is just a length to make it easy for me. It means that the distance cannot be broken down. All right, so we end up with 3 instead of 2. If the mass is a basic quantity, yes, it is a basic quantity. It cannot be broken down. So I'm going to carry on the mass as it is, times. The acceleration, is it a basic quantity? No, it can be broken down. We have broken down the acceleration into length divided by time square. We have broken down the acceleration before into length, so it will be divided into length divided by the time square. This is for the acceleration, times. The distance that we agreed, it is just a length. It is just a length. So we can simply say that the moment it had been broken down into multiple physical quantities, all of them are basics. The mass is a basic quantity. The length is a basic quantity. The time is a basic quantity. The length is a basic quantity. There is no breakdown anymore. We cannot break down any one of these physical quantities. Why? All of them are basic quantities. Then, your objective is just to represent these basic quantities in the SI system and the American system. So the moment, for example, the moment. Here, let us work with the SI system, which is the international system. We said that it is a mass times length divided by time square times length, right? What is the basic? So we're going to say that the unit of the moment in the SI system, what is the basic unit of the mass? It is in kilograms times the length. What is the basic unit of the length in the American international system? It is in meter. Times another length, which is another meter, divided by the time, which is second square in the international system. This is going to give us at the end kilograms times meter square over second square. This is the basic unit for the moment in the international system. How about the American system, the USCS system, unit system? So we said that the moment, it is the mass times length divided by time square times another length equals. So it means that the moment, its unit, the unit of the moment will be the mass in the American system. It should be in a slug, as we discussed, times the length in the American system. It should be in foot, times another foot for the other length, divided by the time, which is in second square in the American system. This is going to give us slug times foot square divided by second square. This is the basic unit for the moment, but in the American system. Make sense? So this is simply how we can calculate or define the units for the two systems, especially the basic unit. Make sense so far? So this is the objective of this part. So far is just to discuss how we can calculate these unit systems and their basic units for these different quantities, whatever they are, basic quantities or derived quantities. Make sense? Now let us consider the prefix. What is a prefix that could be added to any unit? We said that any physical quantity should be described by a number and a unit. So this unit, it could be like one of these basic units, or it could be the unit itself that would be included or incorporated with some of the prefixes. So all of these are different prefixes that are mainly used in the SI or the International Unit System. For example, like tera, giga, mega, kilo, hecto, deca, DC, centi, milli, micro, nano, pico, all of these, and there are more. All of these are prefixes that could be added to any unit. For example, I could have, like for example, when we say that kilometer, it is two parts. This unit, it is a unit, yes, but this unit has two parts. One part is the prefix, the second one is the unit itself, which is meter. So the meter, it is a unit, but the K, it is not a unit. The K, it is a prefix for this unit. This prefix adds value to this unit. For example, like the kilo, it is equivalent to 10 power 3. So for example, if I said that I do have 1 kilometer equals to 10 power 3 meter. It means that you can get rid of the prefix and replace it with a value. Every one of these prefixes indicates a multiplication factor or indicates a value. Like the kilo stands for 10 power 3. The tera stands for 10 power 12. Like for example, we may have terabyte. So the byte, this is the unit. But the tera, it is a prefix. We may have gigabyte. So the byte is the unit. The giga, it is the prefix for that unit. Giga is equivalent to 10 power 9 and so on. Like we may have megapascal. So the pascal, it is the unit. The mega, it is the prefix for that unit. So you should distinguish. We may have units which are blank with no prefixes. We may have other units that comes with a prefix. Like for example, the centimeter. The centimeter, it is entirely as a unit, but it has two parts. One part is the centi, which is C. This C in the centimeter unit stands for centi, which is 10 power negative 2, and meter, M, stands for meter. Meter, as we discussed before in the international system, the M or the meter, this is the basic unit for the lengths for the international unit system. But we may have millimeter, we may have centimeter, we may have micrometer, we may have terameter, we may have gigameter, we may have megameter, we may have kilometer, we may have hectometer, decameter, decimeter, centimeter, millimeter, micrometer, nanometer, picometer. So it means that any one of these prefixes can be added to any unit, whatever it is. It gives a multiplication factor to this unit. Like for example, we knew from the high school that the 1 centimeter is equivalent to 10 negative 2 meter. It means that to convert from 1 centimeter to meter, you have to divide by 100. Okay, so why we are doing this division by 100? Because the centi is equivalent to 10 to the power negative 2, as already shown here in this table. So all of these are different prefixes that we could add them to give a multiplication factor or a certain value. Every one of these prefixes indicates a certain value or a multiplication factor to that unit. And any one of these prefixes can be added to any unit, whatever it is, like kilograms. The kilograms, it is not one just single unit. It has two parts. The kilo, it is not a unit. It is a prefix. The gram, it is the unit. So kilogram, we said that 1 kilogram, it is equivalent to 10 power 3, 1,000 grams. So the gram, it is the unit. The kilo, it is a prefix to that unit. So it means that the unit, it could come with a prefix. You should distinguish between the prefix and the unit itself. Meter, it is a unit. Second, it is a unit. So these are the basic unit, the unit themselves. But the prefix could be any one of these. Like as I said, the tera, it is equivalent to 10 power 12. Giga is equivalent to 10 power 9. Mega is equivalent to 10 power 6. The kilo equivalent to 10 power 3. The hecto is equivalent to 10 power 2. Deca is equivalent to 10. DC is equivalent to 10 negative 1. So as you can see, starting from this line, the exponent became negative. Negative, it indicates a smaller value. Like for example, like the centimeter, it is lower. It is smaller than 1 meter. But the kilometer, it is bigger than 1 meter. So if the exponent is positive, this indicates a bigger value. If it is negative, indicate a smaller value. Like the centi, it is 10 to the power negative 2. The common unit for the centi is centimeter. It is 10 to the power negative 2 of meter. M stands for milli. You should distinguish between. So that's why the millimeter, we write it as double M. MM. So the first M is the prefix, which is the milli. The second M is the unit itself, which is meter. So that's why we say millimeter. So the first M, it is a prefix equivalent to 10 to the negative 3. Micro, which is this symbol micro in the Latin word letters, so it is micro, it is equivalent to 10 to the negative 6. N stands for nano, which is 10 to the negative 9. P stands for pico, which is 10 to the power negative 12. And we do have angstrom, which is 10 to the power negative 10. And we do have atto, we do have femto, we do have so many other prefixes. It means that there are so many prefixes. Every one of these prefixes indicates a multiplication factor that you can remove it and substitute by its equivalent multiplication factor. Make sense? And to understand these prefix things, it is highly important if you decided to work on the unit conversion. So far, we were discussing the different types of units that would have basic unit, we do have derived unit, we do have basic quantities, we do have derived quantities. Now we need to discuss the conversion, how you could convert from one unit to another unit. Whatever in the same unit system or two different unit systems. Now we're just gonna focus on the international unit system and how we can convert. For example, if you do have centimeter, how you can convert it into meter. If you do have kilometer, how you can convert it into meter. Megameter, how could be converted into meter, and so on. So how we can convert from one unit to the other, you should understand these prefixes. Every one of these prefixes indicates a multiplication factor. Your objective is just to replace. If there is a multiplication, if there is a prefix that should be added, you should divide by its value. If it should be removed, you're going to multiply by its value, as I'm going to show you. Make sense? So let us consider this example here. How about, for example, if we have kilonewton, 8 kilonewton. So this is the value. Kilonewton, it means that Newton, it means a force, right? The unit, the Newton indicates a force. So this is a physical quantity that has a value of 8 kilonewton, and we need to convert it into Newton. So the unit is kilonewton. We need to convert the unit into Newton, not kilonewton. So it means that we have to get rid of the K. The K, it is a prefix. So going back to this table again, the K, the prefix, its value is 10 to the power 3. So to remove, remember, to remove a prefix, multiply the number that is given times the value of this prefix. The K is equivalent to 10 to the power 3 or 1000. It means that what you're going to do, I do have 8 kilonewton. I need to get rid of the K. So multiply the 8 times 10 to the power 3, which is the value of the K. So to remove, to get rid of any prefix, multiply by its value. Very simple. So to convert from kilonewton to Newton, what you should do, I should remove the K. I need to get rid of the K. I need to get rid of the prefix. Go to the table. How much is the value of the prefix? K. The kilo, it is equivalent to 10 to the power 3. So multiply, to remove it, multiply by its value. So it's going to be 8 times 10 to the power 3 Newton, which is going to be equivalent to 8,000 Newton. Make sense? This is how we can convert. Deal with the unit and the prefix is going to be much more easy to do the conversion, the unit conversion. How about, for example, if we do have 25 micrograms, and I need it in terms of grams. It means that I need to convert the unit from micrograms to grams. So what you should do, I need to get rid of the micro. I need to remove the micro. So to remove the micro, I'm going to multiply the 25, which is this number, times the value of the micro. How much is the micro? Go back to the table. The micro, it is equivalent to 10 to the power negative 6. 10 to the power negative 6, it means that I'm going to multiply 25 times 10 to the power negative 6, which is going to give us 0.00002425 grams. Or 25 times 10 to the power negative 6 grams. This is how we are converting from micrograms to grams. We need to get rid of the micro, we multiply by its value. How about, this is a little bit tricky. Here we need to convert from micrograms to kilograms, not to grams. So we have to do two things. First, we have to get rid of the micro. Second, we have to add another prefix, which is kilo. So we agreed that to remove any prefix, you should multiply by its value. But to add a prefix, you're gonna divide by its value. Very simple. So again, to remove, you just gonna multiply by its value. But to add a prefix, you just gonna divide by its value. Very simple, right? So if you decided to, if you would like to remove or get rid of any prefix, multiply by its value, divide or add a prefix, divide by its value. So here to convert from micrograms, to kilograms, we have to do two things. First, we have to remove the micro, then we are going to add the kilograms, the kilo, not the kilogram, just the kilo, the prefix. Here we are talking about the prefix. The value of the micro, it is 10 to the power negative 6. The value of the kilo, as we found it from the table, it is 10 to the power 3. So this means that this 50, it should be multiplied. So we're going to have a fraction here. So it should be multiplied because I'm going to remove. So it should be multiplied times 10 negative 6. And it should be divided by the 10 power 3. Why the 10 power 3? Because it is the equivalent to kilo and the kilo will be added, it should be divided. So if you are going to add a prefix, divide by its value. If you are going to remove a prefix, multiply by its value. So I'm multiplying times 10 negative 6, dividing by 10 power 3. This is going to give us in total, if we would like to sum these together, this will be equivalent to 50 times 10 to the power negative 9, right? Because to combine these exponents, you can have negative 6, negative 3, because this negative 3, this 3 is located in the denominator, so it should be negative. It's going to give us 10 to the power negative 9. So do the multiplication, this is going to give us 50 times 10 to the power negative 9 or 5 times 10 to the power negative 8 kilograms. So now we converted from micrograms to kilograms. We removed and added. So consider this rule. Very simple. How to remove, how to add a prefix. Deal with it like a prefix. Like 60 kilopascal, the Pascal, and we need to convert it to Pascal. So the Pascal is the unit itself. The kilo, the K stands for kilo, which is the prefix. Now it is very easy. We just need to get rid of the kilo. To get rid of the kilo, to remove the K, so we should multiply the 60 times the value of the kilo, which is 10 to the power 3. This is going to give us 60,000 Pascal. How about if we would like to convert? This is a little bit tricky here. 40 meganewton. So N uppercase, this is Newton. And the M uppercase stands for mega. This is a prefix. So the M uppercase, it is mega, which is equivalent to 10 to the power 6. This is a prefix. So we do have meganewton, and in the denominator we do have millimeter square. Millimeter square. So it is a little bit tricky. We need to convert it into Newton over meter square. We need to convert it into Newton over meter square. This should be square here. So how we can do this conversion, I'm just going to explain it to you. So it is 40 mega Newton divided by millimeter square. I can write this millimeter square so you won't gonna be confused. This could be written as 40, the same number, mega Newton divided by millimeter square in this way. That is fine, right? Anyway, this is the square of the millimeter. So we do have two prefixes here, by the way. The first one is the mega. The second one is the milli in the denominator with the meter. Make sense? And we need to convert this unit into Newton over meter square. So how we can convert? In the top or in the numerator, we have to get rid of this m. It means that we need to get rid of this m. We need to get rid of this m and m uppercase and m lowercase, which is the milli. This is the milli. And this is the mega. Right? This mega from the table is equivalent to 10 to the power 6, but this milli is equivalent to 10 to the negative 3. Based on the table, going back to the table, the milli is equivalent to 10 to the power negative 3, but the mega is equivalent to 10 to the power 6. So we have to get rid of these two prefixes, but we will not add any more. So there is no addition, there is removal. There is getting rid of these two prefixes. So on the top here, so what I'm going to do, I'm going to have the 40. And since you do have a fraction, so I should have the fraction here as well. On the top, I have to get rid of this mega. So it's going to be equivalent to 10 to the power 6 Newton. And this is the fraction. So I remove the m multiplied by its value. How about in the denominator? Now I'm going to move to the denominator. It would seem that you're already dividing, but you are not actually multiplying. I need to get rid of m. So I do have this bracket, parentheses, squared, right? And the basic unit or the main unit, it is meter. I need to get rid of this m, which should equivalent to 10 to the power negative 3. So 10 to the power negative 3. I am multiplying, but since this milli is already located in the denominator, so I'm multiplying times the unit itself. I'm removing this m, replacing with its value, adding its value, multiplying its value, which is 10 to the power negative 3. This divider is located in the denominator and would seem that you already dividing, but in fact you are not dividing, you are multiplying by the value of the milli. Why? Because it had been removed. It should be removed to convert to the new unit. Make sense? So, can for example do more calculations here, simplification. So we're going to have the 40, 10 to the power 6, and I'm going to have the n on the side. This should be on the top. In the denominator, I should have the 10 to the negative 3 squared. Right? I'm just distribute this square over these two terms. That is fine. This is what we knew from mathematics. We can even distribute this square over the 10 to the power negative 3. And then we're going to have over this side the meter square. So I'm just distributing the letters or the units, or distributing this square among the letter or the unit and the numbers. So I'm just trying to have the numbers separate. This is the main unit that we are seeking. It means that your objective is just to do the multiplication of all of these things, all of them together, to end up with how much is 40 mega Newton per millimeter square, how much in terms of Newton over meter square. So this is going to give us, do the multiplication, 40 times 10 to the power 6 divided 10 to the negative 3 squared. So you're going to do the multiplication of 2 times 3. This gives in the denominator 10 to the power negative 6. So this will be 40 times 10 to the power 6 divided by 10 to the negative 6. Can we collect these two together? Yes, we can collect them together. This Newton over meter square equals 40 times, this should be 10 to the power negative 6. Just let me remove this thing. Okay. So this should be meter square, right? So 10 to the power negative 6, it will be moved in the numerator to be 10 to the power 12. You're just gonna sum 6 negative 6 gives 12, and the as exponent Newton over meter square. So this means that the 40 meganewton over millimeter square is equivalent to 40 times 10 to the power 12 Newton over meter square. This is how we can convert the unit, by removing these two prefixes. In case that even if one is located in the denominator, that is fine. Just remove it and multiply by its value in the denominator where it is located. This is how easy, if you consider this prefix concept, this make easy the conversion of the unit much more easy. So simply, this is a very simple rule. To remove a prefix, multiply by its value. To add a prefix, divide by its value. Very simple. Make sense? So this is also one of the things that we should consider. And we basically, you're gonna do all of these unit things, the unit conversion, this unit system, you're gonna use them a lot through the entire 4 years. If you study for your major, whatever your major is, mechanical or industrial engineering. So it is highly important to know how these unit systems, their importance, we said that their importance is located in this way, that in order to describe, fully describe any physical quantity, should be completely described by a value followed by a unit. Without the unit, there is no physical meaning, there is no sense for such a physical quantity. These unit things are important, and to know how we can convert from one to the other is highly important as well. There are some other tables that are included here for your reference, okay, but mainly we won't gonna focus on them. The thing that we're just gonna focus on all the time, this example that I solved here. But it is highly important to know these tables, and even throughout the 4 years of your studies, in many of the textbook, at the end of the textbook, you're gonna find appendix that include these unit system. So it is common thing, since you study engineering, to know how these units are working and how we can convert from one unit to the other one. Like for example, some of the important conversion units also is the liter, how we convert from liter to meter cube. Liter is a unit of measuring volume. So like the liter, 1 liter is equivalent to 0.001 meter cube, which is it means that the 1 liter is equivalent to 10 to the power negative 3 meter cube. Also, you should understand that 1 Newton is equivalent to kilogram times meter divided by second square, and we have demonstrated this before in this example of the force. That the force, it is kilogram meter per second square, which is equivalent to Newton. You should understand this thing, whatever, for this course or the other courses that you are going to study for your major. I'm just trying to highlight here the most important unit conversions that will be important to know them for your study for engineering. Pascal also, it is equivalent to Newton over meter square. It is highly important to know that Pascal, which is a measure of pressure, measure of stress, measure of many important physical phenomena that you're gonna use as engineer, as it is equivalent to force per area. It is equivalent to Newton per area. Pressure, it is a force per unit area. So it is a force, Newton, divided per area, which is meter square. So that's why the 1 Pascal is equivalent to 1 Newton per meter square. The joule, which is the measure of, or the unit of an energy, since we are dealing with engineering application, and some of this application there should be energy, like the engine of your vehicle drive energy, gives energy. So the energy, the measure of any energy, of any work, of any heat, so the heat, work, energy, all of these are energies. Their unit, it is joule. The joule, it is equivalent to Newton times meter. But Newton divided by meter squared, this is Pascal. The watt, it is the measure of power. It is joule per unit time. It is energy per unit time. So that's why the watt, it is joule divided per second. Also, it is important to know that the watt, it is equivalent to joule divided per second. Also, definitely to know the conversion from the different temperature systems or unit from Celsius to Kelvin. That the degree Celsius is equivalent to Kelvin negative 273.15 degrees. This is how we can convert from Kelvin to Celsius or vice versa. Also, but here in this table, we're still working in the same unit system, which is the international unit system, the metric system that we are using here in the UAE. For example, there are some other ways. For example, for the US system, like the mass in the US system, it is a slug. How about if you would like to convert from one system to the other? Like, for example, if the mass is given in the American system, can we convert it or find its equivalent value in the international unit system? Yes. The one slug is equivalent to 14.5939 kilograms. This is the one slug, how much it is equivalent in terms of grams. This is also one of the things. But basically what we are trying to do is either to stick to international unit system or to stick to the American unit system all the way till the design of your system. Like, for example, if you are doing design calculation and you are working in the UE, so definitely the unit system, it is metric. So you're going to use all the units in metric system or the international system. But if you are already doing the same design in the United States, you have to do the design calculation following the American system of units. Make sense? So it means that it is not all the time that we're converting from one unit system type to the other one. No, we stick to one unit system and we finish the entire design or this time problem with one unit system, or either this one or this one. But barely we are moving or converting from one unit to the other one. But if we needed to do, this table would be helpful in that case. Like, for example, to convert from 1 pound, which is a measure of the force in the American system, to Newton, which is a measure of the force in the international system. The force, the unit of the force in the SI system, the international, is Newton. In the American system, it is pound. How we can convert from pound to Newton? 1 pound, it is equivalent to 4.4482 Newton. How we can convert the pressure or the stress? You don't know what does it mean stress yet, but definitely you should know what does it mean pressure from high school. Pressure, it means a force per unit area, like you pressing your hand over the table. So it means that you are applying a pressure because there should be a surface area for your hand over the table. So there is a force over per unit area. This gives a pressure. So the pressure in the American system, it is 1 psi, which is equivalent to 6,895 Pascal in the metric system. And so on the energy, it is pound foot in the American system, which is 1 foot times pound, which is equivalent the energy in the metric system or the international system, it should be in joules. So the 1 pound foot in the American system is equivalent to 356 joules in the metric system, and so on for the other units. So it means that we can convert, we do have ways and we do have tables that we can use them for conversion from the American system to the international system or from the international system to the American system. Make sense? All right, so that's it for this unit part and today's video. The objective over this video is just to show you this unit system, to understand what does it mean a physical quantity, and to discuss the unit systems and how we can do conversion from one unit to the other unit. Especially if we are working in the international system, it is highly important to know how you use this prefix concept. It is the easiest way to figure out the unit conversion using these prefixes, whatever to add or remove. Add, it means that you're going to multiply by the value. Remove, you're going to divide by its value. So this is what we discussed over today's video. The next video, we're going to move to another topic, which is very important, which is the force analysis. So these two topics will be covered over part 3 of the mechanical design. Over part 4, as I mentioned in the start of this video, we are going to continue the other topics like stress, tensile test, engineering materials, dynamics, factor of safety, and so on. Make sense? So the next video or the next meeting or lecture, we are going to discuss these forces, the forces that in machines, and what does it mean force, how it would be related to the energy, and different forms and different types of the different types of forces. Then we are going to consider a very important topic, which is how we can achieve static equilibrium to objects that's subjected to set of forces. This is gonna be the typical thing that you are going to do for the statics class. So over this part, we're gonna go have an overview of these different types of forces. This will be important topic as well that will be covered over different videos for the part 3 of the mechanical design. Okay, so that's it for today, and thank you so much for the watching, and see you in the next meeting.